Hello, and thank you for joining me for another video. Today we're going to be looking at matrix multiplication. First of all, I'm going to explain what a matrix is. You can skip this part, although it would only be about 20 seconds. A matrix is a kind of like a table of numbers. So this is an example. 2, 1, 9, 4. And we say that this is a 4 by 3 matrix, and we write it as 4 by 3. Because it's got 4 rows and 3 columns. And the rows come first, and the columns come last. So this is a 4 by 3 matrix. So, now I'm going to teach you how to multiply matrices together. You've probably learned how to add two matrices together, but let me just try and teach it to you quickly. 8, 9 plus 7, 5, 2, 1. Say we've got these two matrices and we want to add them together. Well, we just add each position of the element together. So we're going to be left with 2 plus 7 is 14. We're going to have 5 plus 5 is 10. We're going to be left with 8 plus 2 is 10 again. And we're going to be left with 9 plus 1 is 10 again. Okay, I haven't chosen good numbers here. Sorry, I've made a mistake too. The first one, when I said 2 plus 7 is 14, that is clearly not right. 2 plus 7 is 9. You can see that what I just did. I multiplied it. But there you are. That's how to add. So we can ignore that for a moment and look at how to multiply two matrices, which is the aim of this video. So when we multiply two matrices, it's important to get the dimensions right, because if the dimensions are incorrect, we cannot multiply the matrices together. So, say we have a matrix of 5 by 7, and we want to multiply this matrix by another matrix which has dimensions 6 by 9. We cannot multiply this matrix. The reason being is that to determine if we can multiply by a matrix, these two numbers must be the same. So we can't multiply those two matrices together, but we can multiply if the dimension of the second matrix was 7 by 9, i.e. if it had 7 rows. Why is this the case, by the way? Well, you'll see in a moment when I multiply matrices, it will become apparent, hopefully. So we can multiply it if the number of columns in the first matrix is equal to the number of rows in the second matrix. So, what are the dimensions of the matrix that we get once we multiply two matrices together? Well, that is the number of rows in the first matrix by the number of columns in the second matrix, which means the answer will have dimensions 5 by 9. Okay, so let's try and see why that is, and we'll do an example to show that. And this example will also show how to multiply matrices. So say we are given a matrix 3, 2, 1, 7, 1, 4 times 9, 4, 7, 2, 1, 5. First thing is, can we multiply these two matrices together? Well, let's see. This matrix here has dimensions 2 by 3, and this matrix here has dimensions 3 by 2. As you can see, these two numbers are exactly the same, so we can. And in fact, the answer will be a matrix of 2 by 2. So that's the answer for the dimensions of the matrix. So it'll be 2 by 2. So, and now we can multiply. The way we multiply matrices is this. We do the rows times by the columns. So, for the first element, which is at the top left, we do the top of the first matrix and the left of the second matrix. So that will be, you'll see in the example, 3 times 9 plus 2 times 7 plus 1 times 1. That will give us 3 times 9 is 27, 2 times 7 is 14, so we've got 54 so far, and plus 1 times 1 is 1, 55. Let's look at this element now. This element is at the top right. So that means the answer is going to be the multiplication of the top row of the first matrix by the rightmost row of the second matrix. Sorry, the rightmost column of the second matrix. So we are left with now 3 times 4 plus 2 times 2 plus 1 times 5. And the answer to that is, well, 3 times 4 is 12, plus 2 times 2 is 4, so we've got 16 when we add them together, and 1 times 5 is 5, so we add them together, you make 21. Let's try and find out this now. Well, that is at the bottom left, so we look at the bottom row of the first matrix and the leftmost column of the second matrix. And this means the answer is going to be 7 times 9 plus 1 times 7 plus 4 times 1, which leaves us with 7 times 9, 63, plus 1 times 7 is 7, so 63 plus 7 is 70, and 4 times 1 is 4. So we end up with 74. And finally, this element of the answer is at the bottom right, so it's the bottom row of the first matrix, just as normal, and the rightmost column of the second matrix, and that means we do 7 times 4 plus 1 times 2 plus 4 times 5, and that will give us, well, 7 times 4 is 28 plus 1 times 2 is 2, so we've got 30 when we add it together, and 4 plus 5 is 9, so 39. And that is the answer. That is how we do matrix multiplication. I'm going to explain to you why the dimensions matter now. So say we had this instead. In fact, let's look at this example again. In fact, let's do it by virtue of a new example. 7, 2, 9, 1, 5, 2 times 1, 7, 2, 9. So, the first matrix has dimensions 2 by 3, and the second matrix has dimensions 2 by 2. So as you can see, these numbers are different, and you can't multiply them together. But I'm going to show you why. So, the resulting matrix is going to be a matrix of 2 by 2. Let's try and do the first column. Sorry, the first topmost element of the matrix. We're going to get, it's the same as normal. It's at the top, so we do the top row and the leftmost column of the second matrix to get, sorry, I've just messed up there, to get 7 times 1 plus 2 times 2 plus 9 times, there's nothing left. That's why we needed dimension 3 here, not 2. We can't actually do it. and that's the result of the dimensions being completely incorrect. So I hope you can see why the dimensions matter. They're extremely important, and without having the dimensions correct, we cannot do matrix multiplication. In the next video, I'll cover more on matrices, including why they're important and how to use them for geometry. For now, I hope you've enjoyed this video, and I hope you get some practice in, because matrix multiplication is incredibly tricky, and you can only learn it through example. But I hope this has given you the necessary theory in which to answer a lot of examples in your textbook. Thank you very much. I'm Seb, and I'll see you for the next video.